So thanks a lot, everyone, to be here. So do not hesitate to, if you have some question, straightforward on the slides, to share it in the chat. Otherwise, at the end, we have a Q&A session. So a few words about me before. So I'm Eric. I have some experience in haptics, both in academics and in industry. Did my share of research and patents deposits, patents creation, and then I moved forward to having different roles in industry, like technical directors of haptics company, and then I created Interhaptics. So what's Interhaptics? In a few words, Interhaptics works a little bit like Unity for haptics. So it allows users to create seamlessly haptics feeling and haptics experiences for their applications without writing lines of code, and allows them to quickly iterate and share their creation across different platforms. So this is a few more what Interhaptics is. So the talk today will be focused on how haptics can bring value to extended reality. So what are the practical use cases that make sense to achieve with haptics? We spend a few minutes to talk about the sense of touch, so how we do perceive the sense of touch as humans. And then we will have multiple practical use cases where we show with the use of Interhaptics how you can create haptic experiences specifically for accessibility, and in a really easy way. And we'll be discussing about how these experiences can bring value to VR, and how these can expand the user accessibility of the use cases. So first things first, what's haptics? Haptics is every kind of technology that is related to the sense of touch. So everything which is around our capability to manipulate and receive a feeling from the sense of touch is haptics. And also all the group of technologies that allows you to feel the sense of touch are targeted as haptics. And for example, the vibration motors on your telephone is haptics, as well as if you have an Apple Watch, that's haptics also. But one thing to clarify at the beginning of this discussion is that we are, from a haptics technology point of view, we are far away from the capability to simulate. So it's today not really possible to simulate realistic touch feeling through haptics technology, because we are really much far away from the capability of the actuator, haptic actuator, to recreate realistic feelings. However, haptics actuators have a wonderful potential to enrich user experience in today's applications without the need to simulate. So this is extremely important to bear in mind when everyone approach the understanding of haptics and the haptics experiences, because it's never good to sell the dream about being able to feel, for example, texture, in VR, while that's not possible with today's technologies. And also, probably in the next 10 years, we will have a lot of problems to arrive there. If you're more interested to know why, there is wonderful publications about that, and I can direct you to that. So let's dive in a little bit on the different use cases, what haptics can bring as a value for VR. So there are more or less 5 different areas where haptics can bring value. So we can, of course, increase user engagement. We can increase immersion and sense of presence. In some cases, we can decrease user fatigue. Then in a lot of cases, if used right, haptics can decrease the dizziness effect. And if applied to virtual reality training, it can increase their effectiveness. One of the items that makes a lot of sense for accessibility is that we can haptics can really increase the user engagement. Yes, I will move back. Apologies. I cannot really see my own slides while presenting. It's too small. So the use cases where haptics make sense at the current stage are multiples. So we do have haptics for. Sorry, I need to turn because I'm not able to see my slide. We can use haptics to give the touch feedback and confirmation for any kind of interactions. We can use haptics for increase the user immersion or increase remote presence or user awareness, and use haptics for notifications. So let's dive in a little bit to these 5 use cases, and let's see what we are talking about here. So the UI confirmation for haptics is really simple to understand. Is what in reality is the touch feedback or a button, or the touch feedback or a slider or a rotative knob. Haptics can be used to enhance and give the user confirmation of that the digital action is happening. It strikes me that still today there is a lot of VR applications where there is a keyboards which they don't have any haptic feedback, and that generates frustration to the user and makes it extremely harder to type in virtual reality, because simply our body doesn't know where to stop when we are clicking the keys. This is one of the really basic applications for UI confirmation. Of course, you can imagine rotative knob with different ticks that are enhanced to be able to have a better control of the interaction. The second case is probably the most obvious, is the user immersion. That means use haptics to enhance the sense of immersion of the user. For example, if you are in a 360 video, you can use haptics to enhance certain kinds of characteristic of the video. For example, if you have an FPS and there is a war scene, you can use haptics to enhance the feeling of shooting cannons. Or if you have a lever or a texture, you can use haptics to enhance the movement of this lever through specific feedbacks. We'll see later on how this is easy with Interhaptics. Then the third use case is remote presence, and is using haptics to convey emotions remotely. For example, an animation of a beating heart in VR, which also gives you the feeling of a beating heart. It's much more engaging from the user. Or, for example, the capability to have a remote handshake, where haptics conveys the action of interactions with the remote person. And this use case have a wonderful potential in the future for everything correlated with telepresence and remote feeling. Then the fourth use case is use haptics as for contextual awareness. So use haptics as a sixth sense, really. Use haptics as the capability to convey information to the user that are impossible to convey in other directions, in other way, or if we are going through a sensory overload. That means that we are already supplying the user too many information through the visual or audio channel. For example, the necessity to turn left, or the necessity or the incoming danger of something that is happening. And this is one of the really cool application of haptics that is not at all explored, which can give the user, especially in virtual reality, a lot of different information, because we have 2 different haptics devices in VR, which are the 2 controllers, which are not usually exploited today. And the fifth one is probably the most obvious, is to use haptics for notification, so notify the user that something is happening. And in this case, there is Apple, which is doing wonderful work with the Apple Watch. and which we're discussing today in LinkedIn with probably one of the participants to the meetup. He's really capable to distinguish. She's deaf, and she's really capable of distinguish which kind of notification she received, a call or an SMS, through the different haptics patterns that exist, and which is really, really great for avoiding sensory overload and allow the user to really use this private channel, which is the sense of touch. So these are more or less the 5 use cases. We will see a more actionable way how to achieve that in the end, but I would like to spend a few minutes on how touch perception works. This will really help a little bit to understand which is the design process that an app creator should go through when thinking about haptics in his own application. Yes, Meryl, I'm talking about you. Thanks for the comment before. Haptics, the sense of touch goes through the perception of tiny sensors that we have in our fingers. So I don't have an idea to switch on the camera, but we have 1,000 of them, and for example, in our fingertip. And this mechanoreceptor responds to how much our skin is pressed or stimulated in different way. We have, and mostly of them are on the surface. We have 3 or 4 kind of them. We don't have to go through this thing. It's not important. The only thing that's important to remember is that when we poke our skin with anything, with our finger, we are touching anything, the local mechanoreceptor near the skin starts to communicate through nerves that goes up to the brain, spiking, which are tiny electrical signals that travels across our nerves and arrives in our somatosensory cortex, and that are interpreted as feelings, touch feeling. And how this mechanoreceptor encode a different touch feeling is not at all understood today. It's not like for eyes or ears, where we have a really good understanding of the different color perceptual cell in the retina, then transmit then in the brain the specific signal of a specific point of our image. Touch is really not well understood today. And also there is also the items that the touch perception is actually really complex. For example, touch perception is divided into tactile and kinesthetic. And tactile is everything which is related with your skin. So vibration, temperature, sleep, contact location, pressure. All of them are perceived through how your skin behaves when you're touching something. And then we have the kinesthetic information, which are mostly about the strength that you are using to manipulate an object and the orientation of your body. These two together are perceived through mechanoreceptors and are transmitted to your brain, and then they are perceived as a touch feeling. And this is quite important to keep in mind, because it will help us in the design process later on. So haptics in general is decomposed in 2. We have an haptics that is manipulation of object. So I grab an object and I manipulate it. And you see why this makes a lot of sense for VR, because we are interacting with object all the time. And the fact that I'm exploring and feeling an object with my hands or my body, or someone is touching me. And this is like a reactive touch feeling. So why this division makes sense in VR? Simply because in VR, the technological chain from hand position acquisition and touch feedback are separated. So there is a complete technological chain that manages how we interact with object, with every interaction system there is around there. MRTK, there is our own, we have Interhaptics have an interaction system, there is a Unity which has an interaction system. And there is a completely separated channel which manages the touch feeling and the touch feedback for the user. However, for manipulation, in reality, they are the same. So our brain is hardwired to use them together. And this is the reason by which we have this strong growth of haptics devices for hand manipulation in VR, like exoskeleton that you see on the screen, which allows to have a more natural interaction with virtual object because you have both the manipulation and the feedback activity, which are closer to reality. So the user is able to interact more naturally. And this is the reason by which, for example, Oculus Quest invested so much to have hand tracking working, or even Magic Leap have hand tracking music that is working, because it's way more natural for the user just to use their own hands because they know exactly how to use them. And Tim, you can comment on it later on if you want. So what about touch and touch feedback? For example, for images, for vision, we know that we see in 3 colors, mostly some see in 4 colors, but more or less the amount of signals that we can perceive is pretty much understood. For sound is the same. We know pretty much well how many different channels, different spectral channels we can perceive with the audio. For haptics and for touch, we really don't know it. We don't really know which are the basic component of the touch feeling, and there is a lot of different theories that are being proposed. There is one of them that I think it makes sense to show here, and which really will help us to understand a way to design haptics in VR. It is the theory of the 15 dimension of touch, which has been proposed by SynTouch, which is a Californian company which is digitizing the touch sensation of fundamentally a lot of materials, and is working in the industry for that experiences. And they propose a 15 dimensions that allows them to describe in detail a touch sensation. However, when you look into that and we cross this with the incapability of today haptics actuators to render well reality, we see that we have texture and frictions which are planar sensation. That means they exist when you are sliding over a surface. And we have stiffnesses, which is a sensation that exists when you are pushing against the surface, or it is a force that is counterbalancing your movement. Then we have a temperature sensation, which is temperature feeling, which allows you to feel the heat and feel the heat transfer. And in these 3 big groups, we forgot about probably the most used haptics sensation in today's technology, which is vibrations. Because vibrations in nature don't exist. They just exist in earthquakes. And vibrations feeling are completely man-made and completely technology-made. So it is natural to say that in this categorization of touch feeling of reality, vibrations don't exist because they are an artificial sensation. But we see that while going into understanding what these 15 dimensions of touch have in common, or at least can create a subgroup that allows an easier way to perceive and to think about them, we see that we have 4 different groups. We have fundamentally 2 sensations which are defined in space. One of them is the texture, that happens when you're sliding over a surface, and one of them is stiffnesses, which are forces, which happen when you are pushing against the soft material, or there is a force feedback that is happening in your use cases. And 2 of them are based on time. One is vibrations pattern, and the other one is heat transfer pattern, which is temperature perception. We see here that right now we have 4 different sensations, and with 4 different digital haptic sensation, we can start to apply and to use these 4 big groups in a practical manner to integrate within digital technologies. These 4 approaches to haptics for different use cases. So, based on this, what we in Interhaptics did, we created a haptic designer based on these 4 different sensations that you see here. If we go in the back of the room, we have a video over there that will help you to visualize a little bit better what's about in this haptics designer. So there will be a little bit of music right now. I invite you to mute the video, and I will be able to talk on top of it. So effectively, we have right now active within our designer three different perceptions. Temperature perception is not yet well developed because the advantage is devices. And within our haptic composer, we can graphically define the feeling that we want our virtual experience to have. And we have all the tools to graphically prepare and create and pre-visualize for example, this texture, the feeling that while interacting with a specific object in virtual reality, we will feel through our controllers. Or if you are using different kind of devices such as exoskeleton, you will be able to feel while using it. Okay, let's go back to the presentation. So we have this haptic designer, which is fundamentally like a Photoshop for touch that allows you to create a digital haptic sensation, which is called haptic composer. And the idea right now is to go through 6 really easy, actionable use cases for haptics that are really common in today's applications. And we see how with really a really well-designed haptics, we can enhance these use cases in a really easy manner, really fast manner, without spending time to code and without investing too much time to understand how the technology works. Okay. So the first one is probably the most obvious, we discussed it before, is the enhancement of virtual keyboards with haptics. And why we should do that? Because while we implement haptics into virtual keyboard tapping, we have a greater interaction control because we have a feedback when we are interacting with the button, and we decrease the cognitive load that the user is forced to support to know that he clicked a button, because otherwise he needs to rely or on the audio channel or on the visual channel. And how can we enhance it? It's really easy. What is the response of the button when in reality while we are touching it? It increases the tactile sensation that we have while we are pushing the finger down, and at a certain point it drops, and we feel this discontinuity. And we see here on the screen that simply by using a stiffness feeling that you can design with a haptic composer, we can define the haptic curve shape that we want this button to have while we are pushing it. And of course, stiffness, we saw before, that is defined in space. So it will be, in this case, defined in centimeters. So it's 1 centimeter of length. And when we are pressing this 1 centimeter, we will feel this increase and then decrease of the haptic feeling, which will give us the information that the button has been pressed. And fundamentally, doing this activity with the haptic composer, it takes a couple of minutes though. The second one is it makes sense also for accessibility, is sliding menus. So if you are rolling and sliding menus, it sometimes is implemented this haptic feedback every time that you are changing a selected area. And when you're changing a selected area, you're giving an impulse to the user to tell him you change it. And this allows to have an easier interaction control. And again, it's easier for the user to use the tactile channel to perceive that something happened. For example, the Apple Watch has this over the scrolling wheel, the lateral scrolling wheel when you're sliding. While you slide a little, when you turn a little bit, you feel that something happened. There is still the sound on of the video, they tell me. I will pause it. Oh, it should be good. We have it's really kind of easy to implement it with Interhaptics, because it's enough to define the rhythm, the spatial rhythm at which you want the haptic feeling to happen. For example, every centimeter in this case, and assign to every centimeter a click that would happen when the user is scrolling. Because again, this is a texture-based system, and texture is defined in space. So like you would define the pattern of icons that you want to select, you can define the pattern of haptics and superimpose it. And this is a second really easily actionable use cases, and this will really help for navigation within UIs. Third use cases, and that's pretty funny, and it's really quite engaging. It's about using haptics. This is, for example, it's a drawing interaction. In this case, in reality, when you are having a drawing interaction, you are feeling the sensation transmitted through your pen, for example, all along the bodies, and you perceive it with your finger. And what you're feeling through your pen, it's a texture. It's the texture of the paper or the texture of the material that you're writing on. Why don't do the same in virtual reality? Why can't we supply the person designing in 3D with a tactile feeling to tell him what he is drawing, and complement the experience of drawing in 3D with a tactile channel, with different feeling, with a different, for example, colors or brushes that he is using in 3D to design. And again, doing this with Interhaptics is extremely easy. You just define the texture, which is a space-based, because you are interacting with space. And you define the different patterns that you would like your experiences to have. And this pattern will help the user to know instinctually what he is doing just by doing it and feeling it through their hands. And this can generate a really, really good feedback in the user, because he comes back to strategies that he uses in reality, and he understands exactly what he's doing, because he is doing with his own hands. And one of the last one is guidance information. So in haptics, in VR, we have two haptics devices, one left, one right. We can use these haptics to tell them to turn left or turn right. And in this case, we can use vibration patterns, where we can modulate the amplitude of vibrations as a function of how much the user should turn. And then we can use this haptic channel to guide the user left or right while he is interacting with your own application. And this is extremely important, for example, for people who cannot really see well or cannot really hear well, and where you cannot really use these two channels and rely on them for them to be able to guide within your own application. And you can decrease the sensory overload and leave the application as is, and use this haptic channel to guide the user in VR. This is extremely interesting, because for the first time, users have two haptic devices in two hands, instead, for example, for a phone, which have just one haptic device. And for phones, these things doesn't work. Google have it for turn-by-turn applications. But the problem is that there is just one actuator, and it doesn't give you any geometrical information. So for phones cannot work, but in VR it can absolutely work, because you have two actuators. And the last one that I want to talk here is about, again, using haptics for complementing and giving contextual information, and is, for example, a distance from an object. And here again, we can use the vibration patterns, and we can modulate vibration amplitude and repetition. to give the user an information how far away he is from an object. You experience this one every day in cars when you have a parking assistance and you have sound that supplies you this kind of information. You can do exactly the same in VR through haptics and not use sound, so giving you, and this is the idea, is to give you contextual information through the tactile channel, which allows you to decrease cognitive overload on the visual and sound channel. And the last one is the interaction confirmation that is really, really useful for training. And it's interesting to enhance grab and release actions while performing a procedural training through two different haptic patterns that allows the user to have a sensory confirmations that he executed an activity. And this is used as a learning reinforcement during the performing of the scenario. And this again helps you to avoid to use too many colors, red colors, green colors, to give the user the confirmation that something happened. And by relying on the touch channel, you can simplify the UX and UI of your application and focus for a clean experience for the user by leveraging the tactile channel to give the user relevant information. If you want to know more, we have a full Udemy course on haptics design for XR with a more expanded version of this first slide and 5 practical use cases in Unity 3D using Interhaptics that you can download for free on interhaptics.com if you're interested in using your application. And 5 different tutorials which explain to you how to use the product for realizing one use case for each one of the 5 categories that I described before. So UI confirmation, notification, remote presence, immersion, and the last one was, I can't remember right now. So it's the 5th one. And in this case, if you want to go more and dig deeper and start your exploring, you don't have to think, and you don't have to learn. Start from zero. We want to give you all the learning resources that you need to start to approach the haptic design for your application, specifically for accessibility. And I close here with a couple of takeaways that haptics can really reinforce and enhance user experience in XR. And the process to think about haptics in VR or in XR can take inspiration from reality, but you need to be reimagined to take it to understand the constraints of haptics technology. Pretty much like the beginning in VR, people were simulating, and then a way to do good VR become widespread through experimentation and user feedback. In this case, we want to give you really a kickstart with a lot of best practices already done, and you can build upon them without the need to do too much exploration. And the third one is that we in Interhaptics provide a haptic composer, which allows really fast interaction of haptics prototyping and implementation, and allows quickly to introduce haptics in your VR application, specifically in this case for accessibility. And I thank you all for your attention. Tim, I leave you the word, I leave you the stage.
Thank you, Eric. That was lovely. I think that's going to be a really great introduction to my talk. I really appreciate how much you spent on fundamentals. And I'm going to delve now into a specific use case. The past 4 years, up until April this year, I had the opportunity to work at Magic Leap on a mixed reality wearable. And so I was on the UX team that designed everything from the operating system, the notifications and so forth, to LED patterns on the hardware, to the haptic patterns. We work closely with the Sonic Arts team to create sound design for the OS too. So I got to touch on a lot of different efforts. So what you see on the left here is the Magic Leap 1 system, composed of a wearable lightware. There's also a handheld controller, which is optional to some of the experiences because you can interact with voice and gesture as well. And then on the belt pack is a battery, processor, audio volume controls, etc. And then on the right is a close-up of the control, which we'll go into more since that's what we'll be talking about specifically. A little bit about my background. So I'd mentioned that I had worked at Magic Leap. Currently, I am director of product design at Faceware. We do facial motion capture. Basically, we have hardware and software that allows performers to capture their facial motions and map them onto 3D avatars. Before Magic Leap, I worked at IBM Watson, dealing with data viz and AI. Wanted to go ahead and show you Faceware Studio real quick. So this is Faceware Studio hooked up to Unreal. Our app on the left, you can see someone wearing a head cam with a camera pointed back at their face. And then to the right, you see Unreal Game Engine with a 3D model of the face mimicking the live face. So that kind of explains conceptually how this all works in one slide. Recently, we had a concert, a virtual concert on Roblox in which Lil Nas X performed a concert, and there were 33 million attendees. So you can see him on the right wearing one of our head cams. I'll talk a little bit about my XR advocacy work. So during my time at Magic Leap, particularly the last year and a half, I worked closely with our Leapable employee group chaired by Bill Curtis Davidson, who some of you know. And we were involved with internal and external advocacy efforts around XR accessibility. There are some examples here on the slide, volunteering with Dan Marino Foundation, also various talks and so forth. Recently, I broadened my advocacy focus more towards XR user data privacy, but I'm happy to come back and revisit some of the things that I learned at Magic Leap and share them with you all. Talking a little bit about the Magic Leap use cases. Here in the top left, you see a social use case called Social, also known as avatar chat, in which you as a user can wear this device and see virtual avatars of your friends. And you have the ability to convert with voice, with emojis, by moving your bodies. So that's one app that I worked on peripherally on the UX team. I was helpful on some of the haptics issues and so forth. Top right is a screens example. The use case that most people think of with a mixed reality wearable is showing a huge display in which Netflix is playing or HBO on your wall. You can do it with this head-worn display. We had an app called Screens that was aimed to do that. Bottom left is a virtual keyboard, which I'll talk more about in a second here. Worked really closely on that. And then bottom right is our launcher, our landing screen for the OS with all the applications around it. To talk about haptics and the work that I did at Haptics, I'm going to go a little bit into the symbolic input aspect. When I joined Magic Leap, my primary task was to design and prototype a virtual keyboard on which people could type with mixed reality, within mixed reality rather. And I was given a prototype control and also some other engineers and prototypers on the team were able to kind of help me towards realizing this first virtual keyboard prototype. What I ended up doing with the control is leverage the different components on it. So we have a touch pad that has force sensitivity. So that was one mechanism. There was a digital bumper on the front, which is just simply a button. And then on the bottom is an analog trigger. And then we have a home button on the top. What you don't see on the components, but is labeled more to the whole device, is 6-DoF. So we have the ability to point in space. And so that's what I used to define the virtual keyboard. Here are some examples of other forms of text entry that I helped lead the design of on our team. The virtual keyboard being on the left, so you can actually see an animated GIF. I'm going to show you a larger video where you can see the example of a numeric virtual keyboard, and you can see the edge of a controller and a 6-DoF ray pointing at virtual buttons. And then the user, what you can't see is the user is pressing the touchpad or trigger to type those characters, and there's haptic feedback there. The mobile app keyboard, a pretty straightforward iOS or Android keyboard, but definitely some interesting roles tied into head pose with the device. So you'd be looking at a particular object, 3D object, and if it had text entry capability or cursor capability, the mobile app on a phone could be used to perform text entry as well. Bluetooth keyboard I worked on heavily. And then voice dictation on the right, which was wrapped into our virtual keyboard. And one of the things from an accessibility standpoint that was really important to me and my team was allowing users the ability to shift seamlessly between these different modalities. So at any given time, you can pick up one device, drop another, cursor control transitions to the new device. I'll go ahead and show you. I'm going to go ahead and mute that video for a second since I can kind of do some talking over it. Basically, what you're seeing here is a virtual keyboard. The user has gone into settings and they're changing the name of the control. To do that, they must point the control at a text field and press trigger or touchpad. And then they're able to type by moving the 6-DoF cursor on those keys and pressing again. There's haptic feedback for hovers, button presses, key presses, and so forth to enrich this experience. You're also able to use touchpad simply. So now you're not seeing the 6-DoF raycast. That's because the thumb is moving along the touchpad and moving that cursor. Go ahead and shift the, one second here. I'll go ahead and shift the conversation to sensory feedback. So now that you understand the use case of typing in mixed reality, we can go into like how we leverage sensory feedback to help reinforce these interactions and make them more accessible. So for starters, you obviously have the visual display and graphics on the display, but you have additionally LEDs on all the hardware. There are 12 LEDs around the touchpad of the control, which are interesting. Often the trick is getting the user to pay attention, notice them, because the control might be out of the way sometimes, but that's another reason we reinforce these interactions with haptic feedback as well as sound feedback. And I was in a unique position to work on all three of these efforts and kind of coordinate the design across them. As you can imagine, some of the more important patterns featured both visual, haptic, and sound feedback all at once. For instance, like pressing a button, for instance, is something we very much want to accentuate with all three, whereas some of the others are purely visual or purely sound. In some cases, purely haptic. Here's a video of the controller. Mostly sharing this with you just so you can see the LED patterns on it. And you'll see them labeled in the bottom right. So this is pairing. And this one here is a sleep pattern. You can kind of see the slow breath. Shutdown is a sunset, kind of radial sunset. I'll go ahead and play that one more time just in case. The reason why I'm sharing that is because I'm going to show some haptic patterns that work in conjunction with these. So there's pairing again, 2 blue chasers around the edge of the touchpad, joining. Sleep is a slow kind of white oscillation, and then the shutdown, which is the sunset theme colors. I'll talk a little bit about our process to evaluate and make decisions in terms of both haptics, in terms of the components and the types of use cases we outline. So I was involved at a pretty early stage where I mentioned I joined when we were looking at the controller, and we had control prototypes, but we did not have a permanent haptic solution in the control. We knew at some point moving further along, we would have to make some decisions in regards to that before we entered mass production. So the UX team, mechanical team, electrical team, and human factors team all worked together to evaluate some different haptic options. So we looked at LRA haptics, linear resonant actuator haptics, which are probably best described as springed pistons, and then also ERM, or eccentric rotating mass haptics, which you can think of as a kind of a lopsided haptic motor moving around circularly. The nice thing about the ERM is that it's very, very powerful and great for like rumbly sensations, but it doesn't fire up really quick. It doesn't have the snappiness nor the impulse that an LRA provides. We also, problematic with the ERM was this repeat typing scenario or repeat fire scenario. So if you were on the keyboard and you were typing very fast or typing a few characters in a row, you'd want to feel those as distinctly different haptic sensations. The ERM doesn't fire up quickly enough to accentuate each of those presses. So that proved to be kind of a deal breaker. In the end, we went with a LRA haptic called the Tough Type. To program those haptics, we built a Unity prototype in which we could alternate 2 variables, pulse count and pulse time. And it sounds archaic, but between those 2 variables, that was enough for us to generate the different haptic patterns across the OS, of which there were about 20. I'm going to show you some of those next, but before I get there, I'd like to mention one of the things that was a real challenge was dealing with things rumbling and shaking inside the control, and that impacted users' perception of premiumness with the control. So we had to try different frequencies that were aligned or misaligned with the resonant frequency of the control itself to get consonant and dissonant results. So yeah, just kind of to bring up the controller itself is yet like another instrument, like the body of the control is a part of this haptic instrument, and that became very clear. I'm going to move to cover some of the specific haptic patterns in the OS that I find most interesting. So I don't know if I'll be able to share my camera on screen today. I didn't see that option, but I can do my best to vocalize and describe these haptics in case we're not able to go that route. So the first pattern is called starting up. If you hold down the home button on the control while it's off, that's the little round button below the touchscreen, for any duration, it's going to fire up in about 2 seconds, and you'll see what we call like a sunrise pattern. While it's firing up, and by the way, it immediately glows bright blue to let you know it's on before that sunrise effect kicks in. While it's climbing up, you're hearing a so basically ascending pitches spanning about 2/3 of an octave. And I'll just go ahead and vocalize that again. It probably looks really interesting with my bird avatar making those sounds. Conversely, shutting down is also 2/3 of an octave, but descending pitches. And that sounds like this. The actual animation is a lot quicker on the device. I don't know why, but that particular GIF for shutting down is quite slow. And then charging, if you were to plug in the control to a charge source, you're going to hear boom, 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 two small lurches about 0.2 seconds apart. And then you will see a graphic LED along the halo or the edge of the touchpad conveying the charge level. The color green, if you are able to see color, indicates a healthy level of charge. But if green is problematic for you, you can use the percentage filled of the halo as an indicator of charge. So in this case, we're about 80% charged. And then lastly, you know it's charging, not just displaying charge, because you see it oscillating on that last level of charge, implying that it's increasing from maybe 80 to 81%. There's also a UI tap on the bottom right. So whenever you interact with the touchpad on the control, there's a nice glowing effect around the touchpad to let you know it's picking up anything. It's also nice just visually in terms of making the device, frankly, just look cool to see someone playing with this thing and seeing it glow as they use it. It doesn't consume too much electrical power. Here are some other more exciting haptic patterns. Well, actually, I mentioned the UI hover and how important it was. The GIF on the top left shows that. So as the user is pointing at a button with 6-stop or via the touchpad and moving across those buttons, you're hearing a boom, 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 very, very soft. It goes such a long way to accentuate the experience of typing on the device or using any kind of buttons. Just having that feedback is huge. We don't even use sound all the time with these kind of hover sounds, but we always accompany with hover. And you notice it very differently when you use, for instance, a touchpad on a physical keyboard where you don't have that haptic feedback going over a virtual button. You'll notice it right away that it's not there. A variation on hover is this UI force press and hold. If you are to hold down the touchpad for 0.8 seconds on a character on a keyboard, you're going to see a series of alternate characters show up. So this is a way of revealing a context menu, and you hear like a kind of accentuating that context menu popping out. And also when you extract object or prism, in this case, bottom left, you see a whale getting pulled out of another volume that contains the whale. So this causes a 3D model of the whale to pop out of that volume. It's accompanied by a poppy haptic and sound. And then you have social fist bump. If you're an avatar and you're chatting in avatar chat, someone can put their real life hand out in front, and a virtual avatar conversing with you can fist bump you. And so there's a nice fist bumpy sound, a sound effect of party streamers and visuals. And from Eric's talk, this is an example of remote presence in haptics that I find very interesting. Lastly, I just want to close with a slide. If you're interested in developing your own haptics, there are resources on the Magic Leap developer site. I didn't work on this particular effort, but if you're a Unity or Unreal developer, you can play around with haptics in your own experiences. Thank you very much, and appreciate it. Thanks, Eric, for having me again.
I think we have a Q&A, if I'm correct, right?
Can I ask my question first?
Of course.
I'm really curious about the haptics composer application. Something like that would have been really useful when we were working at Magic Leap creating these patterns for our control. I wanted to know if you could describe some challenges in developing that in a way that was user-friendly. It seems to be quite a challenge to create something that visualizes something that people are used to feeling.
Thanks for the question, Tim. It's a challenge that is not yet solved, so it's an ongoing challenge. The biggest hurdle that we faced is how we were able to represent haptics in a visual way. And what was the way to do that? And this is where we spent most of our activity is, okay, the design process is something that it's pretty much stoked on how the haptic renderer in the background works, but how we were able to give a preview of haptics without giving them any haptics feedback. So for this reason, we found 3 methods, one different for each one of the 3 mechanical feedback. One is textures, vibrations, and stiffness. For vibrations, for texture, we have the representation of the surface. So we see here in the background with the video, on the bottom right, we have a 3D preview of the virtual surfaces that the user would feel. For the vibration, we had a visual preview of a square that was smaller or bigger as a function of how strong the haptic was, and you were able to visualize the pattern. And for stiffnesses, that is still the hardest today. We are not really satisfied on how we're doing it. We have some cursor where the function of the shows how one finger press the material and what would be the source profile. So these are 3 ways that we found to represent haptics over there. Does it answer to your question?
Yeah, thank you. I'm interested in exploring the software more. Did you have a question for me?
Yes, and it's about how long was the, if you can share, of course, how much time did you took to nail your haptics experiences, and what was the activity that took most of the time?
That is a great question. Yeah, I didn't do such a, I didn't clearly break down the timeline. So when I started at Magic Leap, I would say we had a haptic in our control that was just kind of there for the time being. It's like a temporary solution. That would have been late 2016, and by early 2017, we were working together as a company to figure out a more final solution. We spent, that said, we spent months and months, probably 3 or 4, just evaluating haptics. So we would be, not myself, but people who work in this area would take a haptic down to the basement into a lab and conduct tests on it and provide feedback in terms of how quick the impulse was. And once we proved that these haptics were responsive enough, they would get put into the control itself, and we would feel like, for instance, how it felt to have a haptic in the body versus closer to the touchpad. We got to try out all these things, but that was also temporary. At some point, we had to figure out how to permanently mount the haptic into the control, and that wasn't my job per se, but I was someone who was basically would evaluate whether it still felt premium after it was mounted in the proper place. We probably spent more time doing that than even coming up with the haptic patterns themselves. The whole time we were working on this, we were obviously thinking about where this was going. In the end, when with actual creation of patterns, I recall creating a list of patterns of instances, mostly interactions, but some notification and wayfinding things that I thought would be crucial for us, and then some more Easter eggs, some like fun things, And so with this list in mind, we basically went with a prototype and just started pressing the control and watching the on-screen graphics and feeling those vibrations. And it's interesting, as sound design team created their contributions, we refined even more. At some point, the sound designers were like, "Hey, we need to bring the ramp haptic up a whole step so that it's consonant with the sound design." So we would make adjustments like that. We would also be adjusting duration. I remember one time when I had the first time I ever had a control in my home. I'm used to having it in a loud office, but I brought it into my home to evaluate. I fired the control up, and the vibration was so strong and audibly loud that I knew right away it wasn't going to be premium to someone taking this out of the box. So at that point, we dropped the amplitude by half. But yeah, Eric, sorry, long-winded answer to your question. There were a lot of little refinements along the way with every edition. Hearing the sound and just seeing the graphics would sometimes result in a change. But we didn't have a lot of flexibility, kind of like what you had mentioned with being able to create the feeling of silk. We were far from that. We were primarily using haptics as a way to accentuate interaction.
Cool. Thanks for the broad explanation. It's insightful for us to know how what was the designing process for that. But I think it's really great. Thanks for sharing.